Saxon Algebra 2, Lesson 28. 2 algebra topics today. Very straightforward lesson. A total of 2 problems. Straightforward, simple, and to the point. You got lucky with this one. The first topic is complex fractions. If you don't like them, I'm going to help you like them. We did them last year. They drive you a little crazy, but let's go through them again, and hopefully this time your brain will be like, oh, that's not that bad. Remember, complex fractions simply means there's more than one division bar, we call it, right? We call them division bars, but they're just the lines, right? They're just the lines in the fraction. A complex fraction has more than one, and our job is always to get it down so it's just got one division bar. The way that we do that, our strategy, is we want to turn the denominators into a 1. Because you know what happens when a fraction has a 1 in the denominator, it goes poof, and it goes away, right? And we don't have to worry about it anymore, it's gone. So that's our strategy when we approach these complex fraction problems. The first one, and I like to give myself a lot of room in these problems, and I hope that you will too, because we have to do a lot of multiplying by things. Right? And so give yourself room to change things. Now, the other thing I want you to always think about are these immortal words from Evie Jones when she learned how to do complex fractions. I don't know, how long was it? 5 years ago? It's been a while. I taught Esther and Evie for a long time. She calls it the smush and flip. That gives us a basic strategy for how to turn the denominator into a 1. First thing we do is we smush it into a single fraction, which John has very graciously done for us this time. Thanks, John. It's already been smushed. And then we flip it. And what we mean by that is we multiply by the reciprocal, because that will turn this into a 1. And that's our whole goal. So we're going to multiply by the reciprocal. However, first rule of algebra says that if you're dealing with an expression, you have to do to the top what you do to the bottom. So we better do the same thing up here, right? Exactly the same. Now, this all goes away because basically what happens, let me write it out. You don't normally have to write this out, but I just want to show you. B times the quantity x plus y, B times the quantity x plus y, that's the same. That's a 1. So when you multiply a number by its reciprocal, even if it's letters and it's a fraction, you can just cross it out. You don't have to show all this. I just wanted you to understand how that worked. Now our denominator has gone completely to 1, and we just need to simplify this. We're multiplying, and look, those b's can go. So our final answer is a over x plus y, right? There's the a and there's the x plus y. And I would normally write that right here, but I did other things there. Okay, we reduced it all the way down to 1 division bar by turning the denominator into a 1. Ah, it was so fun. Let's do another one. Okay. How many are we doing of these? Just 2. Okay, this one looks different. But I don't want you to let that worry you. All you need to worry about is go to the denominator. I always go downstairs first. And I always think about my grandma's basement, which was super creepy, and it had a lot of spiders, and it had a big scary furnace. And I was telling this to some students once, and they said, well, why did you go down there? Like, don't even go down there if it's creepy. I'm like, dude, that's where we slept. And granted, we slept like all the way around the farthest way, but I had to go past some spiders to get to it. It was terrifying. So I always think of my grandma's basement when I do these, but I always think of go down the stairs all the way to the basement and deal with that first. Okay, smush and flip. It's already been smushed. This is one cute little fraction. Sometimes John's going to give us separate fractions and we have to put them together before we can take the reciprocal, but he's being nice to us so far. So we're ready to flip. We want to multiply by the reciprocal. That's going to make it cancel and go to 1, but before I even do that, I'm going to rewrite it. I'm going to do top and bottom, right? Now that can go away because that has poofed into a 1. You don't have to write it out like I did last time. I just wanted you to see it. Now we look at this and see, oh look, the a plus b's will cancel. Even though we're adding within, we're canceling the whole quantity. We're not canceling just part of it. So that's why it's okay to do that. Because I've ranted and raved, right, about how you're not allowed to cancel when you're adding. Well, that's canceling individual pieces of the sum. Here, we're just wiping out the whole thing. So our final answer equals A over C. Yippee. I love when this big creepy thing reduces all the way down to the cute little thing. It's beautiful, right? Let's just have the fun of that. Those lines mean it's disappearing. I wouldn't want you to be confused about that. All right, complex fractions. We're back in business. Part 2. Rationalizing denominators. No, that does not say demons, although it looks a lot like it, doesn't it? I think it's quite interesting that the word denominator can be abbreviated to denoms, and it looks almost exactly like demons. I think that's quite apropos. But let's remember how this works. It says simplify, and then it gives us this expression. Expression because there's no equal sign. Oh, this is supposed to be a 5, sorry. Okay, oh, let me write it over. That makes me sad. 3 over 2 times the square root of 5. All right, here's the deal. You might not care that there's a pig house in the denominator of this fraction, but the community of mathematicians of which you are now a part objects very strenuously to that. We don't like it. We don't want it. It's not okay. We have to get rid of it. How do we get rid of that? Multiply it by itself. If we do it to the bottom, then we better do it to the top, right? Now, this is beautiful because we know that to show you the long way, this is then going to become 2 times, we can put the pigs in together, or we could even multiply them, right? But whichever way you want to look at it, 2 pigs in the house comes out as 1, or we can look at it as, oh, square root of 25, that's 5, right? There's different ways to think of it. But in either case, once you've written these 2 together, you can simply bring them out as a 5 and multiply it by the 2. So now our denominator has become a very cute 10. And we've bumped the radical sign up to the numerator, and that's where it stays. And I completely understand if, as a Padawan mathematician, you go, we still have a radical, it's just in the numerator now instead of the denominator. How is that any better? Well, you know, the older and sager mathematicians among us, they get a twinkle in their eyes and they lay their finger alongside their nose and they say, oh, you guys are so cute, you little junior mathematicians. It just is better because the denominator is rationalized, right? And that's what this whole thing is about. We're not rationalizing the whole expression, we're just rationalizing the denominators. So, don't let it freak you out. Okay, one more problem. All right. Example 28.4. I'll try to copy this one without screwing it up. Okay, so this looks a lot like the last one, right? So we go, oh, I know what to do. We multiply the square root part of it. We can just leave the whole number alone. We don't have to worry about that at all. Just multiply the square root by the same thing, top and bottom, and we'll get 3. This would be times 12, right? So it would become 36 2 square root of 12. That's the right answer, right? Well, kind of. But then we realize, oh, square root of 12 can be reduced, and 2 over 36 can be reduced. So this isn't wrong, but we've got some more work to do, all right? I don't want to do that work right now. What I want to do is rewind, and what I wish I could do is like make the video go backwards, right? My voice go backwards, that would be really cool. But just pretend that's happening. That was me making the backward sound. What I want to do is before we get into all of this, I want to look at this and go, ah, this could be reduced. So I want to fix that before I start rationalizing things. So I'm going to break this out. Let's see. I know it's 3 times 4, and that's 3 times 2 times 2. There's my little prime babies. These guys can come out as a single, not a 12, but a 2, right? That was when I was doing this. So now I'm going to have my problem become, oh wait, it should be 2 on the top. 3 stays in the pig house, a 2 comes out. 2 times this 3 is 6 times the square root of 3, right? Because that's what's left over. All right? Now I only rationalize the 3 instead of having to do the whole 12. I like to make my numbers smaller before I make them bigger. So then these go together and make a 3. And so then my final answer would be 2 square root of 3 over, and I could reduce here, couldn't I? 2 and 6. This would become a 3, and that would be a 1. So I'll take that away and make it over 9. All right? That's the right answer. Now let's see if we can reduce this and make it come to be the same. 12, we already said, breaks out to 3 times 3. No, 2 times 3 times 2. Sorry. Right? The 2 2's come out. The 3 stays in. So that would be 4 times the square root of 3 over 36. And then I can reduce the 4 and the 36. This goes to a 1. This goes to a 9. And I get the same thing, right? Square root of 3 over 9. There's the square root of 3, and there's the 9. So I get the same answer. But my advice to you is reduce your radicals first. Keep your numbers small. It just makes them a little bit more manageable. And I'd rather do the work at the front end than get to the end and be like, oh, it's not done yet, all right? So in either case, it's okay if you don't catch yourself and you just go ahead and multiply through by the big number. It's fine, you'll still get the right answer. You just have a lot more simplifying work to do at the end. If you can catch yourself to simplify your radicals and then cancel just the regular numbers too, that's kind of a general rule. Always cancel when you can. It just makes the calculations easier and gets you to the answer faster. Guess what? That's all. That's all. We're already done. I'm so sad. Lesson 28 is over. Good thing I have 2 more lessons to teach to advanced students. Okay, guess what? Done. Goodbye.